California is famous for earthquakes, but what if the state's most active volcano is not the one most people picture? What if the volcano with the most recent eruption in California is not a broad, instantly recognizable cone on a postcard skyline, but a summit that many visitors pass on the way to lakes, snowfields, and steaming ground? Lassen Peak fits that description. It stands at the southern end of the Cascade Range in northeastern California, inside Lassen Volcanic National Park, and its recent eruptive history is the reason it still matters in any serious conversation about California's volcanic future. That setting is not just scenic background. Lassen sits in one of the most geologically varied volcanic landscapes in the western United States, where jagged peaks, hot water, fumaroles, and young lava features all sit within the same park boundary. The National Park Service describes the park as home to steaming fumaroles, clear mountain lakes, and numerous volcanoes, and notes that hot water continues to shape the land today. In other words, Lassen Peak is not an isolated mountain with a dead volcanic label attached to it. It is part of an active volcanic system whose surface features still point to heat below. Lassen Peak itself is a lava dome, and that detail matters. Lava domes are built from magma that is thick, viscous, and unable to travel far from the vent. USGS explains that high silica magma such as dacite can erupt explosively when it reaches the surface, producing ash clouds and pyroclastic flows, while the same magma can also extrude more quietly to form steep-sided domes because it is too viscous to flow away. USGS glossary entries say rhyolitic lava, which is also high in silica and viscosity, tends to form thick blocky flows or lava domes and commonly erupts explosively. Lassen Peak belongs to that kind of volcanic behavior, slow to spread, but capable of sudden violence. That is one reason Lassen does not look like the classic cone-shaped stratovolcano that many people imagine when they hear the word volcano. USGS says Lassen Peak and its neighboring lava domes are not typical stratovolcanoes like Mount Shasta or Mount Rainier. Instead, the Lassen dome field is made up of numerous individual vents, each generally active for a few years to a few decades and then quiet again. That pattern is important because it shows Lassen is not defined by a single central plumbing system that behaves in a neat, predictable way. It is a complex volcanic field with a history of repeated dome-building eruptions spread across a broad area. The scale of that dome field is larger than many visitors realize. USGS notes that Lassen Peak formed about 27,000 years ago and is one of more than 30 volcanic domes erupted over the past 300,000 years in the park. A USGS fact sheet says the peak rises more than 2,000 feet, or about 600 meters, above its surroundings and has a volume of about half a cubic mile, roughly 2 cubic kilometers. That makes it not just a volcanic summit, but one of the major dome structures in the region. The mountain's steep profile is a direct consequence of lava that could not travel far before solidifying. The eruption sequence that made Lassen famous ran from 1914 through 1917. It began with steam-driven explosions caused by magma interacting with groundwater, a common opening act for high-silica volcanic systems in the Lassen area. USGS describes that sequence as a steam explosion phase followed by extrusion of gas-depleted magma that built and destabilized domes. On May 22, 1915, Lassen produced its strongest explosion of the period, and the National Park Service says ash fell as far as 200 miles, while USGS reports ash reaching about 280 miles, or roughly 450 kilometers, to the east. That eruption was the most powerful in the series, and the last major eruption in the Cascades before Mount St. Helens in 1980. The impact was not limited to ash drifting across state lines. USGS says the strongest eruption destroyed a 3-square-mile area, now known as the devastated area, and the eruption sequence also produced pyroclastic flows and lahars that swept down the northeast flank of the volcano. Some of those lahars traveled more than 12 miles, or about 19 kilometers, from the volcano and destroyed homes along Hat Creek. That matters because it shows the hazard was not only airborne ash, it was also ground-hugging volcanic debris and water-laden mud flows moving fast enough to reshape the landscape and damage property far from the summit. This is the key to understanding why Lassen Peak is called California's most active volcano. Active does not mean it is erupting constantly. At Lassen, it means the eruptions are recent enough that the volcano cannot be treated as a relic. The National Park Service says geologically recent volcanic activity is the best guide to forecasting future eruptions, and it notes that the most recent eruptions in the Lassen area were the relatively small events from 1914 to 1917. USGS also states that at least 70 eruptions have occurred in the past 100,000 years in the Lassen region, including 3 in the past 1,000 years, with the most recent in 1915. That record is much younger than the eruption history of many other California volcanoes. That contrast becomes clearer when Lassen is compared with Mount Shasta. USGS says Mount Shasta is also an active volcano, but its most recent surface eruption was about 3,200 years ago. Its activity is episodic, with long quiet intervals separated by shorter bursts of eruptions. By comparison, Lassen Peak's last eruption was about 100 years ago, which is why the park and USGS continue to classify it as active in a practical hazard sense. Mount Shasta may be more famous and more imposing in the landscape, but Lassen has the more recent eruption record. That difference is what gives Lassen its unusual status in California. The surface of the park reinforces that point. Lassen is not all silent rock and alpine scenery. The National Park Service says the park contains steaming fumaroles and numerous hydrothermal features, and that hot water continues to shape the land. Bumpass Hell, the largest hydrothermal area in the park, is accessible by a 3-mile round-trip trail, about 5 kilometers, and opens to a 16-acre basin, roughly 6.5 hectares, filled with mud pots, steam vents, and boiling pools. Other hydrothermal areas such as Sulphur Works, Boiling Springs Lake, and Devil's Kitchen show that the system is still thermally alive. Those features are the visible expression of heat circulating beneath the ground. Bumpass Hell is especially useful as a clue to the broader system because it shows that the park's geothermal energy is not confined to a single hole in the ground. The National Park Service describes it as the largest hydrothermal area in the park, with a boardwalk giving access to part of the basin. The same park guidance warns that ground that appears solid can actually be a thin crust over boiling acidic water or mud, and that off-trail visitors have been seriously burned in the past. That warning is not just about visitor safety. It is also evidence that the hydrothermal system remains active enough to make the ground itself unstable, which is exactly the kind of surface behavior scientists watch around restless volcanic centers. Those hydrothermal features do not automatically mean an eruption is imminent, but they do show that heat remains underground. USGS says partially molten rock resides beneath at least 7 California volcanoes, including Lassen Volcanic Center, and that these systems can produce volcanic earthquakes, gas emissions, hot springs, and ground movement. In a June 2024 report on an earthquake swarm at Lassen, USGS said the brief swarm did not point to a magmatic origin, noted that hydrothermal earthquakes can happen because of deep magma heat, and concluded that the likelihood of an eruption right now is low. That is an important distinction. Seismic activity at Lassen can come from the hydrothermal system itself, not just from fresh magma moving upward. The hazards at Lassen are real, even when the volcano is quiet. USGS says high silica magma can produce explosive ash clouds and pyroclastic flows, and that dacite magma can first erupt in steam-driven blasts before forming unstable domes. When domes grow, their steep sides can collapse and generate additional pyroclastic flows that race down slopes and valleys. The park's hydrothermal areas add another layer of concern because the ground can hide acidic water and mud beneath a thin crust. So the hazard map for Lassen is not limited to one eruption style. It includes explosive ashfall, ground-hugging pyroclastic flows, lahars, and sudden failures in areas where hot water and steam weaken the surface. That is why monitoring remains central to the story. After Mount St. Helens in 1980, USGS intensified monitoring of active and potentially active Cascade volcanoes. For the Lassen area, the agency says monitoring includes periodic ground deformation measurements, volcanic gas emissions measurements, and continuous data from a local network of 9 seismometers sent to USGS offices. The California Volcano Observatory, formed in 2012 and based at Moffett Field, now monitors potentially hazardous volcanoes across California and Nevada. It uses GPS receivers, seismometers, and multi-gas spectrometers to track deformation, seismicity, and gas emissions that can appear weeks to months before an eruption. That monitoring network is not abstract. It is designed around the things volcanoes usually do before they erupt. A volcano that is inflating, shaking, or changing gas output is sending signals that can be measured. At Lassen, the task is complicated by the fact that not every earthquake swarm means magma is rising. USGS has made that point clearly in recent reporting. Brief swarms can reflect hydrothermal activity linked to the heat of deep magma rather than new magma moving to the surface. That means scientists have to separate ordinary volcanic background noise from the kind of unrest that would suggest a shift toward eruption. It is a system that rewards caution, not assumption. Could Lassen Peak erupt again? The honest answer is yes, but not on a schedule anyone can predict. The National Park Service says volcanoes in the Lassen area can remain inactive for centuries or even millennia, which is why recent activity matters so much when forecasting future behavior. The same NPS page says the most recent eruptions were in the 1914 to 1917 period, and that geologically recent activity is the best guide to future eruptions. That does not mean a new eruption is overdue. It means the volcano is still active enough that the possibility cannot be dismissed. Long quiet periods are part of the pattern, not proof of extinction. The larger setting explains why Lassen exists at all. The Cascade Volcanic Arc is the surface expression of the Cascadia subduction zone, where the Juan de Fuca Plate sinks beneath the North American Plate. USGS says volcanism in the Cascades occurs because of that subduction, and another USGS synthesis says the Cascade Arc extends roughly 1,250 kilometers from Lassen Peak in Northern California to Mager Mountain in Canada. Lassen sits at the southern end of that chain, which means it belongs to a much larger tectonic system rather than a local anomaly. The same plate process that feeds volcanoes farther north is the process that built Lassen in the first place. That broader context also helps explain why California cannot afford to think of volcanoes as a distant problem. USGS says 16 young volcanoes are spread across the state, and magma resides beneath at least 7 of them, producing earthquakes, gas emissions, hot springs, and ground deformation. Lassen is one of the clearest examples of why that matters. It combines a recent eruptive past, a still warm hydrothermal system, and a monitoring network built to detect change. It is easy to focus on earthquakes in California and overlook volcanic hazards, but the state's volcanoes are active components of the same geologic landscape. Lassen Peak makes that point more plainly than almost any other mountain in the region. That is the real surprise behind the label California's most active volcano. It is not saying Lassen is erupting now. It is saying the mountain has the most recent eruption record, the most obvious hydrothermal signs of lingering heat, and the most direct evidence that the system beneath it is still capable of change. It is a volcano whose history is recent enough to matter and whose future remains open enough to keep scientists watching. Lassen Peak is famous not because it is always active, but because it proved within living memory that it can still turn from quiet to explosive. That is what keeps the question alive today. Is Lassen Peak simply resting between long episodes, or is the next subtle change already beginning deep underground? The longer view makes Lassen Peak even more intriguing because its modern activity is only the latest chapter in a volcanic system that has been building, collapsing, and rebuilding for hundreds of thousands of years. USGS says the Lassen Volcanic Center has experienced hundreds of eruptions scattered across about 500 square kilometers, or 200 square miles, during the last 825,000 years. That means the famous summit is not an isolated event in geologic time. It is one expression of a much broader volcanic field that has repeatedly shifted its activity from place to place. The mountain that visitors see today is only one part of a landscape shaped by older centers, overlapping eruptions, and long, quiet intervals broken by sudden unrest. That pattern is why Lassen Peak can seem deceptively calm. The park's volcanic record shows that eruptions do not always return to the exact same vent, and that a dormant-looking summit can sit inside a living volcanic province where the next eruption may emerge in a new location. USGS and the National Park Service both emphasize that the Lassen system includes multiple volcanic domes, craters, and young lava features, not a single cone with a simple plumbing system. In practical terms, that means future activity could involve not only Lassen Peak itself, but also other parts of the volcanic center, which is one reason hazard planning there has to consider a wide area rather than one mountaintop. The 1914 to 1917 eruption sequence remains central because it showed how quickly conditions can change. USGS notes that on May 22, 1915, Lassen produced an explosive eruption that sent ash as far as 300 kilometers, or about 185 miles, to the east. The same eruption sequence devastated nearby terrain and helped establish the scientific value of the area as a natural laboratory. The park's creation in 1916 was directly tied to that eruptive episode and the unusual combination of volcanic activity, hydrothermal features, and accessible alpine terrain. In other words, the mountain's recent past did not just mark a moment of local disruption, it reshaped how the region was understood and protected. The danger today lies in the fact that the signs of life are still there, even when the volcano is quiet. USGS explains that ongoing monitoring at Lassen includes earthquake detection, deformation measurements, and gas observations, and that the California Volcano Observatory keeps watch on potentially hazardous volcanoes across the state. This monitoring exists because volcanic systems often telegraph change through subtle shifts before erupting. Yet Lassen is also a reminder that not every signal means magma is rising toward the surface. USGS reported that the June 24, 2024 earthquake swarm at Lassen did not indicate a magmatic origin, and that hydrothermal earthquakes can be caused by the heat of deeper magma interacting with water and rock. The system can be restless without being on the verge of eruption, which makes careful reading of the signals essential. That distinction between heat and eruption matters for public safety. The hydrothermal areas at Lassen, including Bumpass Hell, show that boiling water and steam remain active enough to alter the ground, while the volcanic record shows that explosive eruptions can happen after long, quiet periods. USGS describes Lassen as a high silica volcanic system capable of steam-driven explosions, dome growth, and associated hazards such as ashfall, pyroclastic flows, and lahars. NPS warns visitors that the hydrothermal ground can be fragile and dangerous because thin crust can conceal scalding water or mud. The same forces that make the park visually striking also reveal why the area cannot be treated as geologically finished. Lassen also matters because it sits at the southern end of the Cascade Volcanic Arc, which extends from northern California into Canada above the Cascadia subduction zone. USGS explains that volcanism in the Lassen segment is the result of the Juan de Fuca oceanic plate subducting beneath the North American plate. That tectonic engine supplies the heat and melt that create the volcanoes along the arc, including Lassen Peak, Mount Shasta, and the rest of the chain. So while Lassen may be the most recent eruptive volcano in California, it is also part of a much larger West Coast system whose behavior is controlled by deep plate motion rather than any single mountain. Seen that way, Lassen Peak becomes less a curiosity and more a warning about how volcanic danger can hide inside familiar landscapes. Its summit is high, its slopes are photographed constantly, and its park trails draw hikers and sightseers. Yet beneath that scenery lies a volcanic center with a long eruptive record and continuing geothermal heat. The most recent eruptions make it California's most active volcano in the plainest sense of the word, not because it erupts often, but because it erupted far more recently than any other California volcano, and still shows the thermal signatures of a system that has not cooled down. That is why Lassen is watched so closely, why its hazards remain part of official planning, and why its name belongs at the center of any serious discussion of California volcanism. The question left at the edge of that discussion is simple. When Lassen Peak changes again, Will the signals arrive quietly enough for people to notice in time?